Hello, good afternoon, everyone. Can you hear me? What happened to my hair? Okay. Hello. Can you hear me? Hello. Yes. Okay. Yeah, because I had my class and then they cannot hear me at first. Yeah. So again, class, if you cannot hear me, please do not just chat it. Maybe I am sharing already the screen. You can talk and then tell me. Okay, can do that. It's okay for me. Okay, so last time our class ended at um, TTO1. Ay, yeah, TTO1. We're done with slide 17 last Tuesday, right? Slide 17 of chapter 2, part 2. Okay, we'll go there. Oh, wait, I will find it first. It's here. Entire screen. Oh, wait, it's slide 17. Okay, so we end here, right? And then I will discuss this. So this one class is the probability density function f. I guess it's just a bonus lesson. You have your p of a less than or equal to x less than or equal to b. So you have to evaluate the integral of f of x dx as a from a to b. Now, there's a property here that if you evaluate the function f of x from negative infinity to positive infinity, the answer is 1 because the maximum for probability class is 1. So it means that if the probability is 1, it will surely happen. Okay? So if you have here two joint density function, x and y. Okay, we have here your x is bounded from a to b, and then your y is bounded from c to d. So it's equal to the double integral of f of xy dy dx. So dy here is in the inner part. So it should be the boundaries of your y here from c to d first. Then dx is the last, so from a to b here in our first integral. Okay, next, or the outer integral. Okay, for this one, again, this is just a property that the double integral from negative infinity to positive infinity is just equal to 1 because it's here because probabilities aren't negative and are measured on a scale from 0 to 1. Okay, we have this as an example. But are we done with this? or not yet? Not yet because it says there. Slide 17. Okay, so you have your f of xy is equal to c times x plus 2y. Your x is bounded from 0 to 10 and your y is from 0 to 10. Find the value of the constant c there. Next, we have to find the probability that x is less than or equal to 7 and y is greater than or equal to 2. So first is the constant c. Okay, so for the constant c, take the double integral of your f of x dy dx. So from negative infinity to positive infinity, and that is just equal to this double integral from 0 to 10, from 0 to 10, because your x there is bounded from 0 to 10 and your y is bounded from 0 to 10. Now, if that is the rectangle, and if it's outside the rectangle class, if it's from 10 to positive infinity, it's 0, it's there. The reason f of xy there is equal to 0 outside that rectangle. So from negative infinity also to 0, it's 0. Your f of xy there is 0. So that is why we only consider the numbers inside your rectangle, 0 to 10. Now, integrate your put c outside and then integrate the first integral here, the inner one. So since this is with respect to y, again you can switch the two here. It's okay to be dx first and then dy the last one because they're both numbers there and then they're both the same. It's 0 to 10, 0 to 10. Okay, so you are allowed to do that. Now, this is dy, so evaluate this with respect to y first. So this becomes xy, and then 2y becomes y squared. Correct? Evaluate that from 0 to 10. Now substitute 10 there in your y, and you have this 10x plus 100 because this is 10 squared here. Now evaluate this with respect to x. This becomes, by the way, the calculator can solve this directly, and you have there 1,500. But if you want to integrate this, you have to write there 10x squared over 2 or 5x squared. And then we have here 100x. Now substitute the x there from 0 to 10. So just only substitute 10 there and you will get 1,500. Now, um, therefore, this one class, since this is equivalent to the double integral from negative infinity to positive infinity, and the property is this double integral is equal to 1. So we have there 1,500 is equal, 1,500 c is equal to 1. Divide 1,500 both sides, and your c there is 1 over 1,500. Now we solve the probability that is missing there. It's probability that x is less than or equal to 7 and y is greater than or equal to 2. So for 7, it's less than 7, so it's from negative infinity to 7 for your x. Now your y is greater than or equal to 2, so 2 to positive infinity. F of xy dy dx. Now class, the minimum number there in the interval is until 0 only. So this becomes 0 to 7. And then the maximum, the positive, since it goes to positive infinity here, the maximum there is only 10. So replace the positive infinity there by 10 and we solve. Substitute now your c is 1,500, then copy this x plus 2y, then integrate this with respect to dy and dx. Now integrate this one. You write 1,500 outside, correct? Now next you have there xy plus y squared. Substitute 10 now, then minus, you substitute the 2 there. It becomes 8x plus 96. Then evaluate this now already because in your calculator you can solve this directly, right? It's 0.5787. Is that correct? Hello? Please use your calculators here, class, to do some practice and typing the integral. But I guess it's okay to you already. Again, the answer is 0.5787. Now we have the expected values. We solve, yeah, previously the x bar and y bar, and then this one class is very similar to that one. Here, your mu is equal to x times f of x dx, where this one is evaluated from negative infinity to positive infinity. This is your probability function f. Then that's it. Your f is probability density function, and this is your mean. This is your mu. Now, if you have two random variables there, x and y, with a joint density function f, we define x mean and y mean, and also called expected values of x and y to be this one. Okay, they are the expected values. Mu1 is double integral of x of fy x dA, and then your mu sub 2 is equal to the double integral of y times f of xy dA. Now, class, here, your x bar and y bar there, class, is the center of mass, right? So here, your mu1 and mu2 as coordinates of the center of mass of the probability distribution. So this 2 now also is the coordinates of the center of mass of the, it's now the probability distribution. So our x bar there and y bar, they are center of mass of what? Of a lamina, right? Yes, okay. Now next we have a single random variable is normally distributed if its probability density function is of this form. F of x is equal to 1 over sigma square root of 2 pi times this one, e to the power of a negative x minus mu squared over 2 sigma squared. So this is the formula. That's for a single um, density function. Now, how about if we have two for x and y? So here, they're given roller bearings that are sold as having diameter of 4.0 centimeters and length 6 centimeters. So in fact, the diameters x, are normally distributed with a mean 4.0 centimeters and standard deviation of 0.01 centimeters. Okay, so mu1 is 4, and then this one, class, is partner, that is your sigma 1, 0.01. Now, while the lengths y are normally distributed with a mean 6.0, that is your mu2, and then standard deviation of 0.01, that is your sigma 2. Assuming that x and y are independent, write the joint density function and graph it. Find the probability that a bearing is randomly chosen from the product line, has either length or diameter that differs from the mean by more than zero point 0.2 centimeters. Okay, so let's start with the x first, f1 of x. So just substitute the value there. Here, this is the formula, right? Okay, wait, we'll go back. Oh, what's happening to the mouse? Look, wait, class. What happened there? No, it's disappear. I'll close it. So the way it is solved, class, it looks like the mass of the lamina. So it's here. This is your f1x, and then 1 over, this one will be the sigma 1, square root of 2 pi, and then um, x minus negative mu 1 here squared over 2 sigma 1 squared. Your 2 sigma 1 squared is equivalent to 0.002. So 2, multiply it with 0.01, and then you square it. No, you square it first. The 0.01, square it first, then multiply it with 2. And this will be the result, 0.002, which is this one. 2 sigma Okay, so the squared is raised only with sigma. So you do the sigma squared first there, and that is 0.01 squared before you multiply it with 2. Okay, now this is your mu1, location of mu1, your x is here, since this is x, and then this one not, this is sigma here, so sigma here becomes sigma 1. Okay, now, if you change the variable there as x, if you change that to y, because this is also for your y, so 1 over 0.01, again, then square root of 2 pi times e to the negative. Now, since this is y, you choose variable y also there, replace that in your x. So you have there y minus 6 squared over, this is 2 sigma sub 2 squared. Your sigma sub 2 is the same with sigma sub 1, 0.01. When you square it, it's 0.0001. Now multiply it with 2. This is the result, 0.0002. Now multiply them. F of xy is the product of the two. We have there 0.01 times 0.01, it becomes 0.0002. Now divide this. 1 over 0.002 is actually equal to 5,000. You try it. And then your pi is here in the denominator. And now your e, you multiply also the two e's there. When you multiply them, there's over there 0.002. Again, 1 over 0.002 is negative 5,000. So it's here. We transfer it already outside, negative 5,000. Now this is now, since that is only positive 5,000, and now we write outside the negative 5,000, so this becomes now positive. It should be x minus 4 squared. So it's positive now outside the parentheses. And here this is negative also, negative of y minus 6 squared. So this becomes positive now because the negative is factor out here already in the negative 5,000, and that is 0.002. This is 1 over this one is 5,000. That is why the 5,000 is there outside. So you have there negative 5,000 times x minus 4 squared plus y minus 6 squared. Okay, and that is now your function. Now the question is, find the probability that a bearing randomly chosen from the production line as either length and diameter that differs from the mean by more than 0.02, and we have this one. Now for your x, the mean here is 4. So since you have there the difference of 0.01, so you minus the 4 with 0.02, so 3.98. Then 4 added 0.02, so it's here until 4.02. Now for your y, started with 6, right? So make it 5.98 because we minus that with 0.02. And the 6 here is added now with 0.02. Again, the mean of the y there is 6, and the mean of your x there is equal to 4. So you have to do it like that in their numbers. So add here 0.02, then add here in the one, in the in the second part, and in the first part class you have to minus that with 0.02. Okay, you perform the double integration, f of xy dy, and then your f of xy dy, okay, it becomes the same. 1 over 0.002, and that is 5,000 over pi here directly. Then evaluate this. Okay, in this numbers, copy the e there, and then that's it. Um, Wait, your calculators cannot solve this. So what are you going to do? There's a double integral here inside. So what are you going to do here, class, is you solve the integral, um, you separate the variables. Yes, because this one is just a product, right? E times this times e to the power negative 5,000 times y minus 6 squared also. Now, you separate the terms with y, and then you separate the terms with x here. And then that's it. You take the derivative individually and multiply it. It's 0.91. Now, what to do, class, since the question there is differ from this means by less of 0.02. So minus that with 1, the answer is 0.09. Okay? Next, we have maximum and minimum values. For this one, it has a absolute maximum here. Then this one has a local maximum because this is not the absolute one. Again, the absolute maximum is here on top, and that is the highest part there. Here is it looks like it's higher here, but it's a local minimum maximum only. Okay, because this is not the highest value. Here it is a local minimum here, and then the last one has the absolute minimum, absolute minimum here. Next, this is the definition for absolute maximum and minimum. So what are you going to do there is for local maximum, if you find an ordered pair A such that for all f of x, y, the f of a, b is always greater than or equal to x. So when x plus y is near a, b. Okay, next. Um, yeah, it should be near the point a, b there. Next, this means that f of x less than or equal to f of ab for all points x, y in some disk with center ab. So the number f of ab is called the local maximum value. Yeah, because as you can see there, this value here is greater than in your f of xy. Now next, that's the local maximum now, your f of ab. Now if f of xy is greater than or equal to f of ab, so when x is equal to y and near AB, then f has a local minimum AB. So just substitute AB here and then substitute um mum okay wait. And that's it. Next we have if f of xy is greater than or equal to f of AB, so it means this value here is larger than your f of AB. All So when xy is near AB, then f has a local minimum at that point, AB. And f of AB is a local minimum value. Okay. Now we have there f if the inequality's definition 1 holds for all points xy in the domain f, then f has an absolute maximum. Again, if all the points xy such that your f there is located higher like this, um all f of xy is less than or equal to f of ab, then ab there class is the absolute maximum. So f has an absolute maximum at ab or has an absolute minimum if all the values like f of xy is greater than or equal to your f of ab here. So there are two cases. Now, there's a theorem that f has a local maximum or minimum at AB, and the first order partial derivatives of f exist there. Then fx of AB is equal to 0, fx of AB is equal to, if y of AB is equal to 0. So, for local maximum and minimum, you solve first class these two values. And if you substitute the AB there in your fx and fy, if there will be 0, okay, so it means that uh, it has a local maximum or minimum at that point AB. Okay, so next we have a point AB is called a critical point, station or stationary point of F. If fxab is equal to 0 and fy of AB is equal to 0, that is what you call class a critical point. And then at the critical point, class it's because that point is located something like this at the tip of that, and then if it's like this, it's at the tip of that part. Okay, so and also, if one of these partial derivatives does not exist, so that is your point AB there is considered a critical point. Theorem 2 says that if f has a local maximum or minimum at AB is a critical point of f. Okay? Again, if your f has a local maximum or minimum at AB, then AB is a critical point of f. However, in a single variable calculus, not all critical points give rise to maxima or minima. Okay? Again, that is for single variable calculus. No, not all critical points give rise to maxima or minima. Now, at a critical point, the function could have a local maximum or a local minimum or neither. Okay, let's start equation number one. This is your f of x. Then, now we solve the fx and the fy. Here, this is 2x, this one is 0, this one is minus 2, this one is 0, this one is 0 because they are all y and constant. Next, f of y, fy, xy. We have 0 for the x squared. This becomes 2y. Here it's 0 because there's only x here, and then this becomes minus 6. Then derivative of 14 is 0, so we are left with that two values. Now, those partial derivatives are equal to 0. We equate that to 0, then solve the x here. So 2x minus 2 equals 0, so it becomes 2x is equal to 2. Divide 2 both sides, your x becomes 1, correct? So here x is equal to 1. Now how about this? 2y minus 6, we equate that to 0 again. For that, if we can get a point class and then AB, and then if your fx is 0 and fy is 0, then that is a critical point. So actually we are showing that this point AB must be a critical point. And we have there 1 for the x, now for the y. So 2y minus 6 is equal to 0. Transfer minus 6 to the other side, it becomes positive 6. So 2y is equal to 6. Divide 2 both sides, your y is equal to 3. Correct? Okay. Oh, wait. Because can I just close my camera? It's here y is equal to 3. So the only critical point is 1, 3. By completing the square, we find f of xy is equal to 4. Okay, why is this 4 here? Because we substitute 1. No, we are going to make it a completing the square. We apply the completing the square here. You have here class x squared minus 2x. So what number are we going to add to make this complete? We add 1. Okay. Again, this is x squared minus 2x. So we add 1 here. We minus 1 also. So 14 minus 1 in our f of x. Y. Okay, next. Y squared minus 6y. So to make it a perfect square, we should add there 9. Correct? Because y squared minus 6y plus 9 is equal to y minus 3 squared. Okay? So we have there, since we are going to add here by 9 and add here by 4, no, no, by 1, not 4. By 1 and 9, we add 10. Correct? We add 10 here. So here 14, we have to minus this with 10. So 14 minus 10, we got 4 here. Okay? Plus, now your x squared minus 2x plus 1 becomes now x minus 1 squared. And your y squared minus 6y plus 9, because we add it also here by 9. We have now y minus 3 squared. Okay, this is now your f of xy. Now, since x minus 1 squared is greater than or equal to 0, this one is greater than or equal to 0, right? And then your y minus 3, when you square it, it means that the number here is always positive or 0. So that is why it's here, greater than or equal to 0. Now, if both numbers there are all greater than or equal to 0, so we get the minimum value, make this 0, make this 0. So your f of xy now is greater than or equal to 4 for all values of x and y, right? Now, therefore, f of 1, 3, where did we get the 1, 3 here? Actually, it's here. The one that we solved, your x there is 1 and your y is 3. Correct? Okay. Substitute it here in your f. Here, 1, 3. So if this is 1, in your x, 1 minus 1, this becomes 0. If your y there is 3, 3 minus y is 0. Square it, it's 0. So you are remaining with the number 4 there. So f of 1, 3 is equal to 4 is a local minimum. And in fact, it is the absolute minimum of f. Then you will say like why it is minimum. Your f of 1, 3 there class is equal to 4. Okay, and then what we did is we get the critical point already, which is the 1 3, and then we substitute it there in our f. The answer there is 4. Okay, and you will say like why this is not the local minimum? Oh, it's here. Your f of xy is greater than or equal to 4 for any values x and y there. So therefore this is the minimum number. It should be 4. Okay, and that's it. And that is the absolute minimum by this one. F of xy is greater than or equal to 4 by this reason. Next, extreme values of f of xy equals y squared minus x squared. Now we take fx first. Fx is equal to the partial derivative of f with respect to x. We have negative 2x. And then for the y here, we have fy is equal to 2y. So the only critical point is 0, 0. Why it is the only critical point? Again, how to get the critical point? Make your fx be 0 and your fy is equal to 0. Then solve the x and y. Correct? Again, it's the definition of your critical point, which is here. I'm so sorry. A critical point if your fxab is 0 and your fyab is 0. Okay? That is why we solve fx and fy first. So equate that to 0, equate that to 0. Then here, if you solve the x here, divide negative 2 both sides. So your x becomes 0. Here 2y is equal to 0. So divide 2 both sides. Your y is still 0. Now the only critical point is 0, 0 that we can get from that equations. Okay? From xy and fx and fy. Okay, now notice for points on the x-axis, we have y is equal to 0, which is here. Look at this point plus. Now, if this is 0 plus in your y, it becomes a negative x squared. If x is less than 0. However, for points on the y-axis, we have if x is equal to 0, f of xy is y squared greater than or equal to 0. Hmm. That's the difference class when your x there is 0. Again, um, when your y is 0, this one is 0, the answer here is negative x squared. Now, if your x is 0, this part here now is 0. So you have the f of xy is y squared, which is greater than 0. Plus your y squared class is always um, positive if your y there is not 0. That is why it's here. So this one is strictly greater than. Thus, every disk with center 0, 0 contains points where f takes positive values as well as points where f takes negative values also. So as you can see here, at the point 0, 0, your f of xy, this is negative, and then the other one, if your x is 0, this one is positive. So there are two different answers, right? Now f takes possible values as well as points. F takes negative values also at that point. Therefore, if that will happen, class, your f of 0, 0 is equal to 0 and cannot be an extreme value of f. It cannot be an extreme value of f class. Again, what to do there? We get the critical point, right? 0, 0. First, we substitute y is equal to 0 here. So the f of xy becomes negative x squared. Okay. Now, again, if x is 0, your f of xy is y squared positive. So you have there two values for your f of xy, a negative x squared and a positive y squared. So if that will happen, we have there f of our 0, 0 now is equal to 0. Correct? Now you substitute the 0 there. So it's correct class. It will be equal to 0. and cannot be an extreme value for f, so f has no extreme values. So as you can see, class, the point 0, 0, if your x is 0 and y, it's here. But it's not a local maximum and not a local minimum, correct? Because our graph, if we have it like that, if it looked like a mountain, the top there is the absolute maximum. Now if the graph is something like this here at the bottom part, so that graph there is the local minimum. But as you can see here, it's not the lowest part, the lowest are here, right? So it's not local minimum, it's not local maximum also, because the top here are the numbers for the local maximum, right? There's still a graph here. Okay, next. You can see that f of 0, 0 is equal to 0 is the maximum in the direction of x-axis. Yeah, it's maximum in the direction of the x-axis, but a minimum in the direction of the y-axis there. Therefore, near the origin of the graph has the shape of a saddle, and so 0, 0 is called a saddle point of f. So class, if you encounter something like this shape, wait, it's too fast. Here, okay, this point here, class, is called a saddle point. Something like it looks like it's the lower value now, but there's still parts there in the lower part. So this is not considered a local minimum. Again, not also considered a local maximum, because local maximum is are found here on top part, not here in the center part. Okay, and that's it. Again, this is called now a saddle point. So if you can see something like this, like there's a wave, and then below it there are some still points there. So the vertex here is a saddle point. Okay, a vertex that is located similar to this one, class, is called a saddle point. Next. Next. So you have this theorem, class. This is a test that you're going to do so that you can determine if this is a local minimum or a local maximum. Okay. Second derivative test. Suppose that the second partial derivatives of f are continuous in a disk with center AB, and suppose that um, fx of AB is 0, then FYAB is 0. That is, so if this is satisfied, your AB there is a critical point of F, right? Then let D of AB is equal to this. We have there the second derivative now of AB times the second derivative of AB with respect to Y minus the fxy of AB, then you square it. Okay? Um, that's it. Wait. Okay. So if D class is positive, that's greater than 0, if this value here is positive, and then your fxab is also positive, this one also is positive, then your f of ab is a local minimum. Now if your D is positive, but your fxx is less than 0, then that is local maximum. Now if your D is negative, again, this one is negative, it becomes negative because sometimes this one class is larger than the product of the two. So if your D is negative, then f of AB is not a local maximum or minimum. And um, this is what you call, class, a saddle point. It's here. Note 1. In case C part, the point AB there is called a saddle point of F. And the graph of F crosses its tangent plane at AB. Okay? Again, that is considered a saddle point if you satisfy the letter C. Okay. Next, we have again the formula for your D shortcut is like this: fxx fyy minus f of xy, then square it. Now, class, there's a note here that when your D is zero, okay, if your D, the one that we're going to solve, becomes zero, the test gives no information. F could have local maximum or local minimum at that point, or it could be AB is could be again, there is no information if D there is equal to zero. So what are you going to do there is do not use the second derivative test and you follow the process that we did here. First, solve the fx and then the fy. Then after that, go to your f of x and then you do some factoring there such that we use completing the square here. For example, you have that two values, right? From the completing the square, and the number here is 4. And we discovered that the f of xy here is greater than or equal to 4, and that is a local minimum. Again, you can use that process in determining the local minimum. If this two fails, if for example class A and B fails, so do not use the method that you're going to do how to get the critical point. Okay, next. Find the local maximum and minimum values and saddle points of f of xy is equal to x plus y squared minus 4xy plus 1. So take the fx first. This is 4x cubed. By the way, class, please study this one because sometimes in the test, it's not like this that they are going to give you in the questions. For example, there's an ln here. Please, you have to be prepared for that. If there's an ln, what to do? If ln x, that becomes, and then you solve the derivative with respect to x, so it should be 1 over x, correct? Okay, so you have to memorize again all the derivatives formula. Now we have here fx is equal to 4x cubed minus 4y because here there's an x here, so the derivative of x to the fourth is 4x cubed. Derivative of y to the fourth is 0. Yes, because there's no x here. Then the derivative of your 4xy here, your y here is considered constant, and your 4 is constant, so that is negative 4y. And 1, the derivative of 1 is 0. So next, your fy, we got 4y cubed from your y4, from y to the 4 here to the fourth, and then this x to the fourth here plus the derivative of that with respect to y is 0. This one has a y here, so the derivative is a constant negative 4x. Derivative of 1 is 0. So we have that. Now what to do, class? Equate them to 0. Please, you do it the second step. After finding your fx and fy, you equate them to 0. And then what happened here is they divided by 4 here also. After equate this to 0, divided by 4, all of the terms. So we have this one. Okay, x cubed minus y is equal to 0, and x cubed minus x is equal to 0. Now what to do now? You have to get the value of your x and y there. Okay, what do you think is the value of the x and y there? Um, I guess, okay, we have this. So to solve the equations, we substitute y is equal to x cubed. Where is that y is equal to x cubed? It's here. Transfer the y to the other side, so your x cubed is equal to y. And also transfer the x to the other side there, your x is equal to y cubed. Correct? Yeah, when you transfer the x to the other side, it's equal now to y cubed. Next, We have to solve these equations. We substitute y is equal to x cubed from the first equation into the second one. So you go back here. Oh, wait. Why? So you go back there. Where is it? Here. Your y is equal to x cubed. No, not that. From the first equation into the second one. Look at your first equation, which is this. Substitute this one here. No, they're just the same. Um, wait, class. Substitute the first one to the second one. Ah, it's here. It's here. Um, your y here is equal to x cubed, and this one, your x is equal to y cubed. Correct? So what to do? 0 is equal to x to the power of 9 minus x. So where is this? It's here. Because from this one class, we have there x cubed is equal to y, right? So here, your y here, replace that with x cubed. So x cubed minus x is equal to 0. So that would be x to the power of 9 minus x. Now factor out x, we have x times x to the power of 8 minus 1. Now, since this one is still a perfect square, so that is difference of two perfect squares, the factor of this is x times x to the fourth minus 1 times x to the power of 4 plus 1. Now, this factor here in the center, this is difference again of two perfect square. So take the square root of the x to the 4, it's x squared. Square root of 1 is 1. So that becomes x squared minus 1, and then partner it with the plus x squared plus 1. So you have now four factors. So there are three real roots: 0, 1, negative 1. So how to get the real roots, class? Again, since these are four factors, you equate all of that to 0. First, x is equal to 0 here, correct? X is equal to 0. Next, the second factor, x squared minus 1 is equal to 0. Transfer 1 to the other side. So that's x squared is equal to 1. Take the square root both sides. The answer is positive and negative 1. It has two answers. Again, class, if you take the square root both sides of the equation, it should be positive and negative answers. Again, if your x there is not defined. Now, if your x there is part of the length, example, do you remember the Pythagorean formula? It's c squared is equal to a squared plus b squared. C there is the hypotenuse. Now, when you take the square root there both sides, the answer is only positive because your c there is referring to the length of your hypotenuse, and it's always positive. So here we have to consider negative numbers because your x here is not part of the height or something that is positive. Okay, it's not defined. So you have there 1 and negative 1. Now for the x squared is equal to positive 1, transfer your 1 to the other side. Again, equate this to 0. X squared plus 1 is equal to 0. Transfer the 1 to the other side. You have there x squared is equal to negative 1. Take the square root both sides, and the square root of negative 1 class is error in your calculator. And by the way, additional information, square root of negative 1 is an imaginary number I. So the answer here is positive and negative I. And it's not here because you have to get only real roots, real numbers, not imaginary roots. Okay? For the x to the fourth plus 1 also, similar. Transfer the 1 to the other side, it becomes negative 1 there. Then take the fourth root both sides. And that is fourth root now of negative 1. And it's error again in your calculator. So only 3 points are there. Now, what to do, class, is you substitute the 0, 1, and -1 here so that you know the partner, the value of your y, its partner. Example, if your x here is 0, oh, x cubed is equal to y, right? So your y is also 0. Next, um, if your x is 1, if this is 1, transfer the y there to the other side. So 1 equals y. So partner 1. 1 also is y. So it's here, 1, 1. Now if it's -1, here it's -1. Cube it. So it's -1. Transfer y to the other side. So -1 equals y. So your y is also -1. Where is that? So you have there 3 points. So we have three critical points now. And what to do? Next, we calculate this. By the way, the time is, boy, this is one is late. 12:53. So I will give you now your 10-minute break. We will continue this one after 10 minutes. Okay. You can read here if you still have vacant time there. Okay. Hello? Hello, class. Can you hear me? Hello? Okay. Mm, did I share already? Yeah. Can you see the slides now? Again, class. I will explain to you how to get the critical points again. Um, First, you get fx and fy. And then after that, equate them to zero. So you will form two equations. For this one, equate that to zero, and then this one, equate that to zero. And then reduce the equations here. Since they are all divisible by 4, you have this one. Now combine these two equations and then solve the value of the x and y there. So that's the next step that you're going to do. Then after that, combining them, you have 3 points here for your x. Now to get the partner y there, you have to substitute it here. Okay, any of the two equations. You can pick the first equation, it's fine. Next, you have their 3 points after. You have the value of your y, so you have their 3 points now. Then that 3 points are the critical points. Next, what to do is we get the second partial derivatives. Again, why we get this? Because we want this. We want to use this second derivative test. Again, we solve the t first, d also, and then our fx xab. Okay? So that we know that it's a local maximum or local minimum. Okay, let's go here. Hmm. Fxx first. So where's your fx? Fx is here. So if we take the second derivative here, 3 times 4, we have 12x. And here there is no x here, so the derivative of this is 0. So only 12x, which is correct. Yeah, 12x squared, sorry. Yeah, because this is cube here. Next, we have here fyy. We solve the fyy. So 3 times 4 here, it's 12y squared. Since this is x here, there's no y, so the derivative of that is 0. So 12y squared for your fyy. Now we solve also fxy. This is fx already. So if we take the derivative with respect to y, this 4x squared, the derivative of this is 0 because there's no y. And derivative of this is negative 4. So we have the f of xy is equal to negative 4. And we substitute that in our what do you call this? Formula for our d of xy. So fxx, we have 12x squared. And then fyy is 12y squared. If you multiply that, it becomes 144 x squared and y squared there. Okay? Now next, minus. You square your fxy. So this one is negative 4. Square it, it's 16. So you have there minus 16. Okay. Now, we test the points class. We have 3 points, right? 0, 0, 1, 1, and negative 1, 1. You substitute that in your D. So 0, 0 class, the result is your x here is 0, your y here is 0. So the answer is negative 16, correct? So it's negative 16 and it's negative. What is it again if it's negative? The rule here is this. If D is negative, this one, less than 0, your letter C, it's not local maximum or minimum. And it says here, note 1, if in case the C there, it is called, the point there is called a saddle point. So your 0, 0 there is a saddle point. Okay, it's here. That the origin is a saddle point. Origin is the 0, 0 point. Okay, next we substitute 1, 1 here. So 1, 1, 1, 1, square it, it's all 1. So 144 minus 16, it's positive. So 128 positive. Now, class, if it is positive, class, you substitute it also to your fxx. Just go with your fxx. So 1 in your x and y in your y. There is no y here, so just substitute the 1 here. 1 squared is 1, and then times 12. The answer is 12. Oh, they are both positive. Again, we have a result that if they are both positive, so that's letter A, it means that the point AB there is a local minimum. Okay? And it's here. Mm, hmm? Yeah, in case A, the F11 equals -1 is a local minimum. Now, similarly, the last point, the -1, substitute it here. -1 squared, it's all positive 1, so this becomes 144 again, minus 16 is still the same, 128 greater than 0. So this is positive in your D. Next, if you substitute in your fxx, the -1, -1, your x here is -1. When you square it, it's positive 1 times 12. It's still the same. It's still positive 12. So it's a positive number. So therefore, again, class, your f of -1, which is equal to -1, correct, is also a local minimum. By the way, where can you get the f of -1? You substitute that class in your f. Your f is here. Okay? So replace this with -1 and y -1. So -1 to the fourth plus -1 to the fourth minus 4 times -1 times -1 plus 1. The answer there is a -1. Okay? Here also, the f11, you substitute that in your fxy, and it's there. That is the local minimum, and this one is a local minimum also. And they're equal, right? -1, -1. Okay, next. So in our critical points that we had here, there is no local maximum. So only saddle point and 2 local minimum. Here, how about this? Find and classify the critical points of the function. Also find the highest point on the graph of f. Okay, what do you mean by the highest point, class? So maybe that is the maximum, right? The absolute maximum. Okay. Solution. The first order partial derivatives are this one, fx and fy. From this one class, you take the first derivative with respect to x and respect to y. So I will not discuss that in detail anymore. You try this. This is correct. Okay. Next, um, to find the critical points, we need to solve the equations. Okay, this one you equate that to 0, and then this one also equate that to 0. Okay, here we can factor out 2x. It's here 2x times 10y minus 5 minus 2x squared. And then this one also we can factor out this to 2. So this one becomes 5x squared. This becomes minus 4. This one minus 4y cubed is equal to 0. Now class, we have here 2x, right? So this is a factor of the two numbers. So your 2x here could be equal to 0. Correct? So if your x here is equal to 0, or this factor here, the 10y minus 5 minus 2x squared is also equal to 0. So you have their two values now. Now if x is 0, what to do? You substitute it here to solve the value of a y. Okay? Oh, what is that? Oh, it appears. If x is 0, oh, this is the next one. If x is 0 class, the y that you can solve there is 0 also because it's here 0, 0 as the critical point. Now, if, oh wait class, maybe I skipped something. I think there is missing. Please wait. Yeah, there is missing. Mm, the next slide says alternatively. Oh, one slide class is missing. Please wait. Um, okay. So if x class is equal to 0, there, equation 5 becomes this. And so y is equal to 0. Where is this? Here, equation 5. If your x is 0, yeah, you partner the x here is equal to 0 in your fifth equation. And then this one also, you partner that with the fifth equation because there are two factors here in your number 4. If this is 0 class, it becomes negative 4y minus 4y cubed is equal to 0. And then what will happen there is factor out that one. Negative 4y times 1 minus y squared is equal to 0. Now, class, negative 4y here, you equate that to 0, equals 0. And then 1 plus y squared, equate that to 0. Now, if you have there 1 plus y squared is equal to 0, transfer 1 to the other side, it becomes negative 1. And that's y squared. Take the square root both sides. It's the square root of negative 1. It's error in your calculator. It's a complex number, so it's not a real number. So you have here the first one, negative 4y is equal to 0. Divide negative 4 both sides. Your y is 0. So we have here a critical point 0, 0. Next, second case is this one, the 10y minus 5 minus 2x squared. Partner that with your fifth equation. So we solve first the x squared, and it's equivalent to this. Now, why we solve the x squared? Transfer the 10y to the other side, then transfer the negative 5, it becomes their positive 5, then divide both sides by negative 2, and you have there an x squared. Now, why we solve that as an x squared? Because here in equation 5, it is x squared here. So we substitute it here, and then we can solve the value of the y, correct? And it's there. Substitute this in your x squared and it becomes like this in equation 5. Okay? This is 5 times x squared. So multiply 5 in all here. 5 times 5y, 25y. 5 times negative 2.5, it's 12, negative 12.5. Then just copy the negative 4y minus 4y cubed. So it's here. Negative 4y minus 4y cubed is equal to 0. So as you can see here, the variables are all y. So what to do, you use your calculator class to solve this. Equate this to 0, and your calculator will give you three values of your y there. So it has three real roots. Now after that, you substitute the values of your y where? Here. In here, you substitute it here in the x squared is equal to 5y minus 2.5. Then take the square root both sides. So only those with positive square root inside class, it's a square root of positive numbers will be the answer for your x. And you will get this x value. Positive negative square root of 5y minus 2.5 because there's an x squared there, right? Now you substitute the three values that you had. For example, first is the y, which is negative 5.5452 here. And there is, x has no corresponding real values because it will be negative here plus inside. Next, if that is 0.6468, it becomes positive and negative. There are two values here. Now for the y, which is 1.89, there are two values also. So you have how many points now? Um, First is the 0, 0 as a critical point. Next, we have this one. So five critical points. The 0.6468, partner it with the 0.85, positive and negative, which is here, this one. We just estimate it for 65 here. And then this one, 8.8567 becomes 0.86, the last one. Here, the 1.989 84 becomes 1.9, and then the 2.64 becomes 2.64 there. Now, you substitute that in your value of your f. Okay. So for the f, it's 0. Second, it's 8.5. Then the last one is negative 1.84. Now, next, in your fxx, you solve your fxx class, then substitute the following points. Even if it's positive or negative here, they have the same result. So that is why the author just they didn't separate the 2 points here, the positive and then the negative, because it has the same answer. It's negative 55.93 in your fxx. The 0, 0, if you substitute in your fxx, this is negative 10. Now, the following are the results, right? Now, if your d is positive and your fxx is negative, it's a local maximum. Next, D positive, another negative for your fxx, that is also a local maximum. And lastly, we have a D there, which is negative. It is a saddle point. Again, if your D is negative, automatically it is a saddle point. Now, class, what do you think is the absolute maximum? Do we have an absolute maximum here? The answer is you go, class, with your value of f. Again, your value of f will determine the absolute maximum. Look at the maximum number here. It's 8.5. Therefore, we have 2 points uh, which are absolute maximum. Okay? And that's it. Actually, this is the graph. Yeah, it has two absolute maximum here on top. Okay? And the saddle point are here. Down here is the saddle point, right? The 0, 0 is a saddle point. Hmm. And that's it. Next, we have, yeah, it's here. Absolute maximum value of f is f, positive negative 2.64, 1.9, approximately 8.50. And that's it. Next, find the shortest distance from a point 1, 0, negative 2 to the plane x plus 2y plus z is equal to 4. So the distance from any point xyz to the point 1, 0, negative 2 is d is equal to the square root of x minus 1 squared plus y squared plus z plus 2 squared. By the way, how are you going to get the formula for the distance? Okay, plus this is how you're going to do. This is x. You minus the first number here. So that's x minus 1 squared. Next, y minus the 0. Square it. It's y squared. Z minus negative 2. The minus negative 2 becomes plus. So it's here z plus 2 squared. And that's it. This is now your distance d. And we have to get the shortest distance from the 2 points. Now, but if xyz lies in the plane is this. X plus 2y plus z is equal to 4. Now solve the z there. Your z is 4 minus x minus 2y. Just transfer the x and the y to the other side. Okay? And so we have, hmm, since your z there is this, you substitute it here in the z so that your formula for your distance contains only x and y. So we have your 4 minus x minus 2y here plus 2. So the 4 becomes 6. So that is why it's here. 6 minus x minus 2y squared. We can minimize the d by minimizing the simpler expression. Now, take the squared both sides. So the square root will disappear. We have d squared is equal to x minus 1 squared plus y squared plus 6 minus x minus 2 y squared. Now, this is your d squared class, and we label it like our function f of xy. Okay, so what are we going to do now? We are going to minimize the d. So what to do? We have to find a local minimum here, correct? This is our f of xy. Okay, by solving the equations, fx is equal to, now get the derivative with respect to x here, and this is the derivative, which is equal to 4x plus 4y minus 14 equals 0. Then the fy here, we have this value, which is equal to this. 4x plus 10y minus 24 is equal to 0. Okay, as you can see, class, there is no squared here. So it's really easy to solve. Okay, your calculator can do this. You just type the two equations here. 4x plus 4y minus 14 equals 0, and then 4x plus 10y minus 24 is equal to 0. Can you do that, class, please? Use your calculators there to type that two equations, and it will give you a value of x and the value of y. Are you done? Am I too fast? Okay. Hello, please try that. And if you are done with it, again, your answer now becomes, okay, it has only one value for x and one value for y, because that are two equations in two variables there, x and y. So we only have one value for x and one value for y. So this is the only critical point that we can solve. Again, what to do, how to get the critical point again. If you can still remember, take the fx first and then the fy, solve them, then equate them to 0, then solve the value of your x and y there. So we only have 1 point here, so that is now your critical point. Now we solve fxx, it's equal to 4. Is it? Your fx is this. To get the fxx, so derivative of this 4x, it's 4 only. Your fyy 10 only, and then fxy, look at your y here, so 4. And that's it. 4, 4, 10. Substitute that in your d. Oh, it's positive 24. In your fxx, you substitute this point, 11, 16, and then 5 over 3. If you substitute this is always positive. So positive of d and positive of f, it means that by the second derivative test, f is a local minimum. And what can you say about local minimum? Again, it will give you the minimum number for your distance d there. So go back to your distance d, which is this. You use this one because there is no x, there is no z here anymore, only x and y, and we get only a pair, right? Ordered pair, which is x and y only, 11 over 6 and 5 over 3. You substitute it here. Again, the distance with no z, substitute x, substitute y there, and you will get 5 square root of 6, 5 over 6 square root shortest distance. Oh, short quiz. For the short quiz class, did I give this to you already? Not yet. Um, can you answer number 7? Number 7 only. Okay, all of you. Um, and then after that, please, you have to write it in a paper and make the solution detailed one. Then send it to my email. Okay, do you know my email? I will type it here in the chat box. So the first three students who will get the correct answer will get the bonus points. It's here. chris.armada@hcmut.edu.vn. Oh my god, I didn't turn on the camera.
Can you show me the question again, please?
Yeah, it's here. Oh, by the way, the slide is available already in your LMS. You can see it there. Number 7. Okay, answer only number 7. Please, you have to write it in a paper. Or if you have there some tablets, you can use your tablet and then write it with your pen there. Again, I will not accept those who are type. Do not type your answer, please. I will not give you the bonus points if you type it. So I will give you like 5 minutes for this. Okay. Maybe 10 because you're going to send it to my email. 8. 8 is enough, I guess. Okay. So only the first 3, okay? Who will get the correct answer. Oh, someone answered already. Class, if you solve the integral, please, if there's an integral still, you have to write the dy or dx there at the other side, at the last part. Okay? Now, if you solve already the integral, the dy or dx will disappear. Okay? Yeah, because yesterday in my class, there's still an integral there, but the dy is not there, so I didn't consider it. even if his answer is correct. Yeah, because the solution there is missing.
I sent you the wrong answer, so can I resend it?
Yes, you can, as long as the others are not yet sending the right answer. 19 and 22. Okay, correct. There is final set. 16, 16, si 16, si 19 wala din. 16, si 16, 19, 20, 26. The number 2. Lang, take si number 2. Find this. Set. Tayo sa laban. Last. Hala na pa din ay. Per 5. Oh, it's time already. Okay. Oh, wait. I share it. I'll open now your answers. We'll just check only one. Oh, who will be the winner? By the way, we have. Oh, why is this? I cannot understand this. Um, can I talk to? Can you talk? Hui, is this who he? I cannot pronounce it. Nguyen Chong. Is this Hui? Hui Nguyen Chong. Can you talk? Hello. Can you open your microphone, please? What is the last? What is the last line? Hello. Hello. Calling. I do not have a mic. Um, can you rewrite the last line here in the chat box? The last line there. It starts with two. Two, and then what is that? Is that zero? Two times zero plus? Hello. Now, I will not consider this if you will not type it here at the chat box. You type your last there. I cannot clearly see it. No, I told you you have to give me a detailed answer. Some of you just use their calculators directly. Hmm. By the way, class, the answer is 4 over 3. So if your answer is not that one, no, my God, all of you didn't send me a detailed answer. Did I tell you, class, that it should be in detail? Did I? Or I didn't? If I didn't, I will consider this individual who used their calculators after the last integral. Did I say that you do it? Hello. Did I say that you're going to write it in detail? Did I? Class, you're not responding. Please say yes, here or no.
Uh, did you mean that after we find out the last equation, we have to substitute y by -1 and 1 into each equations?
Yes. So I told you that.
Uh,
What?
no. So at the last step, I just use calculator to find out.
I didn't?
Yes, you didn't announce that.
Okay. So I will accept those who use calculators. Yeah, but I will give points also to Fam and Ko. How to pronounce this? ID number 2251026. Yeah, her answer is correct. 4 over 3, and it's in detail. Maybe I can just show this. Okay, so to those three who give me the answer. It's Wing Nguyen Trung. Next we have um Kang Hong Fook, and the third one who sent me the correct answer is Fook Vuduk Tien. So congratulations everyone, and including you, Pham An Koi. It's Koi. It's letter I. Okay, and that's it. So congratulations to those who got the correct answer. Okay, next. Wait, where is the next one? Mhm. Oh, before we start with the next topic, by the way, we are now reviewing some questions in for midterm, and then yes, we will answer some of the questions. Okay, so after this one class is next meeting. If I missed some topics that we didn't discuss, I will discuss that also. By the way, next meeting is our last meeting before midterm because I am not allowed to teach for the fourth week. By the way, if you want me to give you a review on that week, it's fine. I am vacant. I can give you my time. Okay. So we will solve some problems there if you wanted to. By the way, I will not share the slides. So I will share it later after 10 minutes. Okay? So it's now time for your 10-minute break so that we will have a continuous discussion after this 10-minute break. Okay? See you after 10 minutes. Okay, it's time already. Ah, okay. So we have here. Oh wait. A production line is utilizing two different types of industrial machines for its operation. The quantity of products produced per day by the production line is determined by Q is equal to 100 x to the power 1/3 y to the power 2/3 units, where x and y represent the operating hours of these two types of machines, respectively. Assume that the total operating hours per day for both types of machines must not exceed 17 hours. Calculate the maximum quantity of products in units of products that the production line can generate in a day. So we are now solving the maximum value. How to do that again? If you get it, again, what to do? First class is this one, Q. You have there two variables. So subject to this constraint. Where is this from? X plus y is equal to 17. Can you see it here? No, it's not here. By the way, it's here actually. This line class assume that the total operating hours per day for both types of machines must not exceed 17. So it will not exceed to 17. So 17 is allowed. So that is why it's x plus y there is equal to 17. And it will not go beyond 17. So 17.1 is not allowed. So only 17. That is why we have there x plus y is equal to 17. Now class 2, um, you solve the y in this one so that we substitute it here in our q. So our q now has only one variable. It's only x. Okay. So we have there y is equal to 17 minus x, correct? When you transfer the x there to the other side, it is now 17 minus x. So your qx now, your new qx is 100 x to the 1/3, and then your y there, replace that with 17 minus x to the power of 2 over 3. Now next, you differentiate q of x. So there's an x here and then there's an x here inside. So what are you going to do? We apply product rule. Okay? We apply product rule here. Um, since this is constant, it's okay that the constant will stay there at the side and take the derivative of the two terms that we're going to multiply. So the answer here is actually um, what he did is he copied the second times the derivative of the first plus, it should be plus, right, for your product rule. Then copy the first, then derivative of the second. Okay. Okay, let's go back. We'll have here 17 minus x to the power of 2 over 3. This is the first term that he has. He used this first. So you have the wait, you have here this one, and then multiply the derivative of the other one, x to the power of one third. So multiply one third here. So one third x. Now one third minus one is negative two thirds. So it should be one third times x to the power of negative two thirds, which is here. The next plus. It is plus, right? And then you will see later why this is minus here. So just make it plus first, and then copy now x to the power of one third. And now we take the derivative of this. Now, what's the derivative of 17 minus x to the power 2 thirds? So multiply 2 thirds here, correct? In the constant part, multiply 2 thirds. After that, um, copy 17 minus x, then 2 thirds minus 1, it becomes now negative 1 third. And then, so it's here, 2 third, and then 17 minus x to the power negative 1 third. Okay. Now, since there's a variable here inside, we multiply the derivative of this. The derivative of this with respect to x, we have negative 1, correct? Because this is negative x here, so multiply negative 1 there. So that is why, class, it is now negative here. Okay? Hmm. Again, for product rule, it is plus, but since we multiply additional negative 1 there, it becomes now minus. Now, what to do, class? This is your q prime of x. Now, equate that to 0. And then after that, you solve the value of your x. You solve the value of your x. Please, can you calculate that? Yeah, you can calculate that immediately. You can type it in your calculator. And your x is equal to 17 over 3. Can you try it? That's too long. Please try that one, class, in your calculator, please. Okay, is it 17 over 3? Correct? Is it a yes? Okay, no one will talk. Hello? Yeah, the other class tried that already, and the calculator will give 17 over 3 there. Okay? And then, since this is your x class and your y is 17 minus x, substitute it here in your constraints, and you can get the value of your y. 3/4 over 3. Now, combining x and y here, this is now your critical point. You remember it? It is now your critical point, right? We take the derivative of our q there, and then with respect to x, and then we equate that to 0. And then after that, we can get these 2 points. Next class, what to do to get the maximum value, just substitute it there directly in your Q. And that is now the answer, 899.5273. And that is here, letter B. Okay? The answer here is letter B. That's the maximum quantity of products that they can produced. Okay, next. Hmm. How about this one? A point M has polar coordinates r sub o pi over 3, with r sub o is greater than 0. In the standard polar coordinate system, x is equal to r cosine of phi, y is equal to r sine phi. Given also that M lies on the circle of equation. x minus 15 squared plus y squared is equal to 225. Evaluate r sub o. When you say evaluate r sub o class, you solve the value of the r sub o there. Oh, what do you think is the answer? Is it A, B, C, D, or E? What's your guess? Ah, wait. So that you can participate, can you type your answers there in your calculator? No, no, calculator. In the chat box. Just guess it. There is no points for this class, and then there is no. It's okay to get mistake here. Um, yeah, I will not record it. Just try it. What letter do you pick? Please pick a letter. Please, A, B, C, D, or E. Hello. Okay, someone answered B. Okay, next. Only one. Yeah, he is the one who answered 17 over 3. Kang Hong Fok. So only one is using calculators. Is using calculator. My God, what's happening to the other students here? Okay, wait. Can you pick a letter now? You are 18 and only one is picking a letter. Just pick a letter class. It doesn't mean if just guess it. Hello. It's okay to get mistake. I will not record this one. Hello. Please pick a letter. If you will not pick a letter class, I will require all of you to open your cameras next meeting. See? A lot is answering now letter B. Only B? There's five letters there, class. We have again, what's the answer of the other students? Again, B is not the answer. So that's a hint. You can pick another letter now. Hello? You just guess it. Five, four, three, two, one. And that's it. Some are not responding. Why? I am I am expecting class that you are listening to the discussion. Even if you are not typing there, at least you are listening. So I am hoping that one. Okay, next we have this one. We solve this. How to do this kind of problem. First, this is the given, right? This is the equation, and this is your polar coordinate r sub o and pi over 3. Now what to do class, you substitute the pi over 3 there in your phi value because that is an angle there. So x equals r sub o. The r there class replaced with r sub o. Okay. So cosine of phi is pi over 6, pi over 3. Here r sub o sine pi over 3. Now, if you solve the cosine of pi over 3, it's 1/2. Then sine of pi over 3, it is square root of 3 over 2. Now we get x is equal to r sub o times 1/2 because this cosine pi over 3 is 1/2. So times that with 1/2, your x is r sub o over 2. Now for your y there is the sine pi over 3 is square root of 3 over 2. So your y is r sub o square root of 3 over 2. So this is now your new y. This is your new x. What to do class? This is very easy. Substitute the value of your x and y there in your equation. So this is x. So x becomes r sub o over 2 minus 15 squared plus the y there. Y is r sub o squared of 3 over 2 squared is equal to 225. Now solve this in your with your calculator. Now since there is no r sub o there in your calculator, you can use x there or the y variable. Okay? X over 2 minus 15 squared plus x squared of 3 over 2 is equal to 225. And you got there two answers because that's a square. The exponent there is squared, so it has two possible answers. What's the answer? The answers are 0 and 15. Is it correct? We got two answers, 0 and 15. Now we go back here in the question. They clearly write it here that your R sub O should be greater than 0. It means that your R sub O will never be 0. Okay? So we have to pick, our answers are 0 and 15. So we have to pick 15, and the answer is letter E. Hmm. And can I see it in the chat box? So got letter E? No, no one. Okay, next. Another question, then you will guess. Okay? And that's
Teacher,
it. Since R sub O is greater
will you post this slide onto
than,
the
huh?
LMS for us to check again?
In the LMS? No, not yet. I will not paste it there. You will see the answer.
Oh, okay, okay, okay. No, no, no. I mean like after class.
I
I
will
mean like
upload this after our class. Okay?
okay,
Yeah,
okay, okay.
because you will see the answer there. Huh?
Yeah, yeah, yeah,
Hello?
yeah. Yes, yes, yes. I understand.
Yeah, it will be after class. The slides for this one. Okay? Yeah, because you'll just see it there and then you can answer directly. Okay, next. Um, oh, critical points. How many critical points? This one class is asking you to solve how many. So if you have the 3 points like 0, 0, 1, 1, and -1, -1 as our example previously, you answer there three if you have the 3 points. So how about this equation? How many critical points does this function have? Can you answer now? A, B, C, or D? I do not pick E anymore. I am sure that the answer is just here in the four letters. A, B, C, or D. Again, do not answer none of the others. It's not good. It's not a good choice. Is it A, B, C, or D? Can I see it now in your chat box? A. Nice guess. A. Who's next? B. Oh. D. Next. Only three? Only three will type the answer. Next, please. Hello, you're all 20 here. My God, it's easy class to type a letter. It's only a letter. What's happening to you? Hello. Now, our rule number two there in our classroom rules is you have to participate actively, right? And you are not participating. Hello. C, D, what else? Ah, so it's complete now. We have now an A, a B, a C, and a D. So who will get the correct answer? Okay, so let's show it now. Okay, so another one B. Okay, you are not allowed to answer it anymore. So only until here. Okay, so better luck next time. Okay, let's answer now. How many critical points does the function have? Okay, first we get the fx right using chain rule. It is 6 here, so put 6 here outside. Then this one to the power of 5, then multiply the derivative of what's inside. Am I correct? Okay, so that is 6 here. Then copy 14x squared plus 7y to the fourth to the power of 5 now. Then derivative with respect to x. So this is 14x squared. The derivative of that is 28x. So 28x times 6 here, we have 168x. And this one. Now, we set that to equate that to 0, correct? And then after that, we have this one. 168 is equal to 0. And then, okay, this factor here, class, if you equate that to 0, it will never be equal to 0. Why? This is to the power of 2, and this is to the power of 4. So the result here is always positive, correct? Okay. So this whole thing here will not be equal to 0. The exponent is, since the exponent is positive, always. Okay, now next. We solve 168x is equal to 0. Divide 168 here, divide 168. We can get an x which is equal to 0. So we have a value x is equal to 0. Next, we will integrate, we will get the derivative of that with respect to y also, right? Okay. So again, 6 there to the here, and then this one becomes 5, and then multiply the derivative of 7y to the fourth. It is 28y cubed. 28y cubed times 6, we have 168y cubed times this one. Now we set that to 0. Again, you have to set 0 for your fy. This is your fy, okay? So this is now 0. So this one, equate this to 0. So 168 cubed, 0. So divide it by 168, then take this cube root both sides. So your y is 0. How about this? This one, class, will never be equal to 0. Do you know why? What's the reason? Because um, this is 14x squared plus 7y to the fourth. And then when you this is positive, this is x squared. The result here is always positive. The y to the fourth here is also positive. Now if your x there is 0, so your y there must be 0 also. So just the same critical points that we can get. You have there x, y, which is 0, 0. So we only have one critical value, the 0, 0 point. So the answer is 1. Oh, who got the correct answer? 1 is letter B. And by the way, congratulations. Who's that one? Oh, Folk Vudok Tien and Nguyen Do Nguyen Hong. Oh, see? It's nice to just guess the answer. Oh, wait. I have a question there asking for saddle points. I will insert that later. Okay, next. How about the next question? Hmm. Which function has domain is enclosed by an ellipse? Okay, class. I will give you a hint here. What to do? Go to your Desmos graphing calculator and you graph all the functions here, and then you have to see something like there. Do you know what's an ellipse? Ellipse looks like an oval. Okay, you can search the definition of an ellipse. Its form is like the circle. It's x minus h squared, but there's a denominator there, a squared, plus y minus k squared over b squared is equal to 1. So actually, a circle is also an ellipse if the a there is 1 and the b there is 1. Okay? So that's it. So which of the following has a domain which is enclosed by an ellipse? Okay, go. Then you write your answer there now. The letters A, B, C, D, or E. Again, class, that's so easy. Please try your Desmos graphing calculator with the two variables. The one with the two variables, please. Oh, what's your answer now? Do you have an answer now? D, D, D. All of you are D? Are you sure it's D? Where's D there? Um, D is fxy um, x minus 9 minus x squared minus 3y squared. So let's try. Graph functions of two variables plus and then just change it here. You have their square root of 9 minus x squared minus 3y squared. Oh, yes. Hmm. This one class is the domain here at the bottom part. So this one is really enclosed by an ellipse. And you got the correct answer. The answer is letter D. Okay, that's it. Next we have hmm, oh, where's the slide? It's here. So the answer there is letter D. Next, how about this? Select a function f of xy whose graph is shown there. Go. I will give you like 5 minutes. Is it okay? So class, please do not use the graphing calculator now. Look at the graph class and then what to do there is you get a point here and then substitute it here. Again, this is the value of your x here, this is your y here, and this is your z, the one that's going up. Your z is your f of xy. Please get a point and then substitute it there, and then if it will satisfy, if they are equal, then that is your function. Okay, okay, go. Again, do not use graphing calculator class, the decimals, in answering that one. Get a point here. I hope that you know how to determine a point. I am really hoping that you know how. I told you already how to graph that one, right? In a three-dimensional space. So look at the value of your x. Is it straight there? In your y also and in your z? Okay, are you done? What's your answer? Oh, you're not answering now. What's your answer there? It's 227. The last message is 222. Now give me now your letters. What's your guess? Okay, I'll count unto five. Five, four, three, two, one. Now, how did you know that the answer there is C? Yeah, the answer is none of the others. Yay, congratulations. It's letter C. Okay, class. What are you going to do is to get a point in this graph. Okay. Do you know this point here? Look, can you see the arrow, the cursor? It's a blue there. Okay. Here, class, your z there is 0 because that's going up, right? Your z here is 0. Now, your x here, this is straight here in your x, which is -2. And now for your y, this 0 here is straight here in the -2 of your y. So your point there now is -2, -2, 0. So 0 is your f of xy, and the -2 is your x, and your y there is -2 at this point. Okay, now you substitute it here. If this is -2 squared, your y also is -2 squared. So that's 4 minus 4 minus 4, a square root of -4. So it's error in the calculator. So A is wrong. Next is B. Again, the fxy is 0. Okay. Now substitute -2 here and -2. You have there -4 minus 4. So -8 is the answer for your B. Here, this is plus. So answer for your D is if you substitute there -2 and -2 in your x and y, it becomes 4 plus 4, it's 8. So your E is the square root of 8, so it's not 0 also in your f of xy. Therefore, the answer is letter C, none of the others. By the way, if you were going to graph that class, the graph is this. Wait. Uh, I try it actually. It's y squared minus x squared, I guess. Charan! Now, see? It's the same with that, right? Then he will say, huh, teacher, are you sure? It's not the same. It's very different. Actually, because it's the same. All you have to do is to rotate it. There's a rotation there that they will be the same. Yeah, like that. Oh, can you imagine it? They are the same, right? No, but I cannot. Uh, yeah, that one. Oh, turn it. Turn it. Oh, look at that class. It's the same, right? Yeah, I told you it's the same. It looks like that, and then there's okay, and that's it. And yeah, it looks like this. Oh, there's a curve there. Okay. Next, we have yeah, and also class. If you have that y squared minus x squared, if you substitute there the -2 in your x and your y also is -2, the result is 0. So it will satisfy that equation, this point here. Okay? The -2, -2, 0 point. Next, how about this? Select a function f of xy whose contour map is shown here. So you use your Desmos graphing calculator class and guess where is it? I guess it's letter E there. Can you try E? And then you can see something like this. There are two many parabolas there. That is the contour map. Okay, so the answer there is actually letter E. Okay, next. Okay, how about this class number 4? This is the easiest of them all. So first, you take the partial of f over partial of z, and then after that you substitute the x and y there are both z. Hello. Who can explain how to solve this? Just imagine everything. Just imagine everything. Can you do it, class? Can you do it like an imagination? Yeah, just tell me the derivative with respect to z. Okay, no one? It's very easy, right? What is the derivative of the cosh? It's the sin. It's the sin or sign with an h, right? Hello. Okay. Oh, what to do here? What are we going to apply? What rule? Hello. No one? You can open your microphone, class, and then you can say something how to do this. Hello. Yeah, I guess you'll have an idea on how to do that. Again, class, this question, class, is the easiest of them all. Well, then you would say, are you sure, teacher? It's the easiest. It's too long. Hello, class. Are you done solving with this? I guess you can solve that like uh 2 minutes or three. It's fine. Hello? Hello, class. No one? By the way, um, the process of solving this class is very easy since it is with respect to z there. As you can see, the sign here has no z, so this is considered constant. This one also is considered constant, so just put it at the side. Now, here, kosh, there's a z here inside, and here there's a z here also inside. So what are we going to do? Just apply quotient rule here, right? See, it's easy, right, class? Yeah, easy. Okay, now what to do? First, copy the denominator, correct? You put the denominator first, and then after that, take the derivative of the cosh. It's sine h of 9 plus 5 x to the fifth plus 6 z to the seventh, and then multiply it with the derivative of what's inside here, which has a z. So 7 times 6, we have 42 times z, correct? Okay, minus. You copy the cosh, yeah, the whole thing here. then multiply the derivative inside here. The derivative here with respect to z is only 2z. So 2z over this one squared, correct? Z squared plus 4 plus 5y to the 6 raised to squared. And that's it, class. That's now the derivative. And that is very easy now because since your x and y are zeros, your z is 1. What will happen here in the sign? X is 0, y is 0. So this one is 0, 0. So that is sine 8. Sine of 8 here. Next here, this is 0 here. Since this is x, y to the fourth is 0 also. This one is 0, this is 0. So the remaining constant here is ln 4. Then cube it. So again, sine 8 at the top and then ln 4 cube here. Next we have, oh my god, what's happening? Okay. Next we have the top. This is the top, right? The z squared is there on top also. But your z there is just 1. Then this is 0, this is 0. So that is now just 1 there. Next, we multiply it with the sine h. Sine h of this is 9 here, then your z is 1. So z to the power of 7 is 1. So plus 6 here. So this is 1 times 6, 6. So that is sine h of 15. Are you listening? So at the top, we have their sine of 8. And then ln 4 cube here. And sine of sine h 15 here. Minus the derivative is the 42z. So that's only 42. So 42 times the cosh. Your cosh is also 15. So cosh 15 over this z squared here is the only one. The rest are zeros. And then you square it. So it's still 1. So only the ln cube is the denominator. So you type it like this class in your calculator. Sine 8, sine, and then parenthesis 8 there, and then a bracket. Now inside the bracket you have there your sine h of 15 minus 42 times cosh of 15 over ln 4 cube. And that's it. You're done with the derivative now. So if you calculate it, oh my god, I cannot calculate it. I do not have an h here in my calculator. Sine 8. Now, where can I find it? No. Do you have your cosh there, class, and sign with an H? Your calculator? Wait, I will try to find. Now, where are you? Okay, what's the answer, class? Hello. Yeah, because I do not have a calculator. I'm just using my phone's calculator. And then there is no sign H here. Are you done? What's the answer? The answer is letter. Can you chat it in the chat box, please? B. I think it's B. Why you just think it? You didn't you didn't compute it? Again, it's sine 8 and then put a bracket. Inside the bracket we have there sine h 15 minus 42 times cosh of 15. Yeah, and then divide the whole thing by ln 4 cube. So all of you answered B. Here you type it B. There you actually the answer is letter B. Correct. Congratulations. And the next we have how about this? Wait, I will not give you that. I want to give you this last question. Oh, this one. This is very easy. How many saddle points does that function have? A. None of the others. B. 3. C. 0. D. 2. E. 1. Oh, we only have 7 minutes. Maybe this is the last question. How many saddle points does that function have? Oh, we just discussed saddle points, class. So I am expecting that you will get them. Again, what to do there? Get the fx, get the fy, then equate that to 0. Solve the value of your x and y. If you have there too many exponent like squared, cubed, so you have too many answers. My God. Hello? What's your answer now? Do you have? That is x minus 5 squared minus y minus 7 squared plus 9. Now, that is very easy equation, class. It's only squared. So maybe in your test, the powers there is to the power of 10, maybe? Do you want it? Oh my God. Are you done, class? Saddle points? Hello? You still have 4 minutes before we will end at 2:50. What's your answer there? Is it 3, 0, 2, or 1? Class, that question, class, is very easy. Oh my God. Do you have an answer now? Can I see it in the chat box? Nah. D, E, E. So many answered letter E, 1. By the way, class, the correct answer is letter E, 1. Wow, congratulations. How did you do that? Um, So this is the explanation. How many saddle points? So first, you get the fx and you get the fy. That's the first steps, right? That you're going to get. Next, equate them to 0. So if you equate them to 0, you can only solve one value for x, which is 5, and one value also for y, which is 7. Okay? Again, the derivative of your function with respect to x is this one has the term with x only, so the two terms here, the derivative of this is 0. Multiply 2 here, so we have 2 x to the power of 5 and then to the power of 1 because we minus this one with 1, right? So this is the chain rule. Next, multiply the derivative of x here inside. The derivative of x is just 1. Okay? Next, we have this one of fy. So y is only here, so the other terms, the derivative that is 0. So 2 times the negative here becomes negative 2, and then y minus 7 to the power of 1 now because we deduct that with 1, right, in the exponent. So that's it. We have this and we have this equals 0 equals 0. Then solve the x, it's equal to 5. And then y minus 7 equals 0. Your y there is 7. So the only critical point is at 5, 7. So we only have one critical point here. Next, oh, to solve the saddle point, you use the second partial derivative test, right? Fxx is 2. From here, your fx is this 2x minus 5 or 2x minus 10 here if you distribute the 2. Here we have negative 2y plus 14. So the derivative of your fx, which is that is 2x there. So the derivative that is 2. That is why this is 2 here. Your fyy is negative 2, and then your f of xy is 0. Okay, because there is, take the fx, your fx here is 2 already. So if you take the derivative of fxy, it becomes 0 because 2 is constant. Okay, so that's it. fxy is 0. Now compute the determinant. I wait. This is fxy class, right? And then in your fx class, there is no y here. So the whole thing is considered constant. Okay? So the derivative of that is 0. Next, you substitute it here. D is equal to fxx fyy minus fxy squared. Your fxx is 2. Your fyy is negative 2. Then your fxy is 0. So this is now negative 4. Oh, your D is negative. So automatically, if your D is negative, the critical point is a saddle point. So since you only have one critical point, you also have one saddle point. The point that it looks like there's, right? And then there's parts of the graph there at the lower part. And that's it. The answer there is letter E. Congratulations. And it's time already, by the way. See you next meeting. Thank you for coming today. Bye. And to those who participated, thank you so much. I really appreciate your participation. And I am hoping that the next time that we have this, the other students will participate also. Okay, bye. Thank you.